Hi, today we'll be looking at how AI has been transforming the diagnosis of conditions like, for instance, lung cancer, pneumonia, tuberculosis, and COPD from machine learning of chest x ray interpretations that boost the diagnostic accuracy of physicians. Now, chest x rays are the most frequently performed imaging procedure worldwide, with over approximately 2 billion scans being taken annually. They are a primary diagnostic tool for detecting a wide range of pulmonary and cardiovascular conditions, including pneumonia, lung cancer, tuberculosis, pleural effusions, and cardiomegaly. However, interpretation errors still remain a major challenge, which ultimately leads to delayed diagnosis, unnecessary medical costs, and also increased morbidity. And studies actually show that approximately 30% of abnormal chest x-rays have been misinterpreted by physicians, with misdiagnosis rates being even higher for non-radiologist physicians. Now, this is particularly concerning given the growing demand for imaging interpretations and the global shortage of radiologists, specifically in rural and emergency settings. Radiologists fast increasing workload, which can therefore result in cognitive fatigue and also reduce diagnostic accuracy. Now, in order to address some of these challenges, deep learning-based AI models have been developed in order to assist automating and perhaps standardizing and enhancing the accuracy of chest x-ray interpretations. And recent advancements of AI, specifically deep convolutional neural networks, have actually shown that AI systems can even match or exceed radiologist performances in certain diagnostic tasks. Now, in this video, we'll be exploring an FDA-cleared AI system introduced in October 2024 in the Nature journal and its ability to improve physician accuracy and its impact on clinical efficiency and its broader implications for AI integration in medicine. Now, before examining the benefits of AI, it is very important to understand the systemic limitations of human-based chest x-ray interpretations. Now, several factors tend to contribute to the diagnostic variability and interpretation errors, and we're first going to start with experience disparity. Now, radiologists undergo extensive training, but non-radiologists such as emergency medicine or internal medicine or family medicine physicians oftentimes tend to just perform the initial interpretations. And studies actually indicate that non-radiologist physicians tend to misinterpret chest x-rays at a significantly higher rate in comparison to radiologists. And next problem is cognitive fatigue. Now, radiologists are expected to interpret thousands of images per day, which therefore leads to increased fatigue and potential decreases in accuracy. And actually, error rates increase significantly after prolonged periods of image evaluation, which goes on to confirm this idea of cognitive fatigue. And also the complexity and the subtlety of these findings, the perhaps vagueness of these images. Now, some abnormalities such as perhaps early stage cancer or even small nodules or mild pleural effusions may be very subtle and easily overlooked. Variabilities in the brightness, contrast, and also the anatomical structures can make detection challenges, specifically in certain images. Now, given these challenges, AI-based decision support systems offer a very promising solution by providing a very consistent and data-driven interpretation, which generally reduces human cognitive load. Now, the AI system evaluated in this study was trained on a dataset containing approximately 20,000 chest x-ray scans from approximately 12 hospitals, and it was tested on an independently and publicly available dataset. The AI model utilized a deep convolutional neural network architecture, specifically ResNet-based feature encoder, in order to analyze and classify these abnormalities. Now, the AI model followed a three-step process, starting with pre-processing. In this stage of pre-processing, it standardized radiographs by adjusting the resolution and removing the axis padding. Next, moving on. Next, it underwent the stage of feature extraction with deep convolutional neural networks, wherein the AI model used ResNet-based architectures in order to encode image features and also produced probability maps indicating the likelihood of certain abnormalities or diseases. And then it was the stage of classification and localization, wherein the AI essentially assigned all of its findings to one of its clinical categories and also highlighted the regions of interest, much like in this picture right here, with bounding boxes, which made the results entirely interpretable for physicians. Now, this specific AI system achieved a very high level of diagnostic accuracy with an overall AUC of approximately 0.976. Now, I think this is a really good time to explain what these AUCs are. Now, AUC is also known as area under curve, is a performance metric that's used in order to evaluate the accuracy of classification models, particularly in medical diagnostic and machine learning-based classification tasks. Now, it measures how well a model can distinguish between different classes, such as normal and abnormal findings in chest x-rays. And the AC value essentially comes from this receiver operating characteristic curve, which plots the true positive rate, the sensitivity, against the false positive rate, which is essentially 1 minus specificity at different classification thresholds. But all of this will make more sense when I explain what sensitivity and specificity are in our next lesson. But in conclusion, AUCs are pretty just accuracy models with values ranging from 1 to 0, and anything above approximately 0.9 is considered as pretty accurate. Now, a critical finding in this study is that AI significantly enhances the accuracy of both radiologists and non-radiologists when interpreting these chest x-ray scans. Now, without AI assistance, physicians had an average AUC of approximately 0.773. But with AI assistance, the average AUC rose to approximately 0.874. But more importantly, AI assistants allow non-radiologist physicians to achieve performance levels that were even just comparable to trained radiologists, as we can see here. This is the threshold, the general average for radiologists, and this is what happened with physicians of other professions when they had AI assistants. Now, from this has major implications for healthcare systems because in settings where radiologists are scarce, this means that along with the aid of AI, other physicians are able to perform to that level. And this clearly shows us that the application of AI in chest x-ray interpretations did definitely aid physicians' diagnostic accuracies, which again, therefore confirms the potential of AI in the medical field. And this brings us to the end of this video. Thank you for watching.